Jai Hind bachcho. Today's session is dedicated to numericals based on combination of resistances, right? So without wasting any time, let's start with the questions. These are the 9 questions which we are supposed to attempt. In each of these 9 questions, we are supposed to find the equivalent resistance between the points A and B. Remember, A and B are the 2 points across which the equivalent resistance needs to be found, right? So let's begin with the first question. Let's start with the first question. Now look students, these are mixed grouping. Some resistors are connected in series while its resultant along with some other resistors are connected in parallel. So that's known as mixed grouping. So we need to redraw the circuit diagram in the simplest form, right? And then proceed. And those resistors in which we are 100% sure whether they are connected in series or parallel, they need to be solved first, right? And the branch AB containing the resistor between these 2 points is to be solved in the last step. So let's start with the first one. Now look students, here it's pretty clear that these 2 are connected in parallel, isn't it? This 5 ohm, this 5 ohm, they are connected in parallel. And in parallel you are aware, net resistance always tends to decrease. These are the 2 resistors, each of 5 ohm. So the resultant would be 5 into 5 divided by 5 plus 5. Why? I'll tell you. In parallel, the formula is 1 by R1 plus 1 by R2. So if you solve it, what you get is LCM is R1 R2 and here you will get R1 plus R2. So R parallel would be equal to R1 R2 divided by R1 plus R2. Am I clear? And also remember, in parallel grouping, the equivalent resistance is less than that of the individual given resistances. In case both the resistances are equal, its parallel resistance would be equal to half of the given value. So, what is the resultant of these two? 5, 5? It's 2.5. 5 into 5 divided by 5 plus 5. So, that will give you 25 divided by 10. That will give us 2.5, isn't it? So, this circuit can be redrawn in this particular manner, like this. This is 5 ohm. This is 5 ohm, and equivalent of these 2, it will be 2.5 ohm. This is point A, this is point B, and this is 5 ohm connected over here. This is 5 ohm. Right students? Now check in this circuit, which resistors are to be solved first. These 2 are connected in series, there is no doubt about it, right? So in series, resultant is R1 plus R2. Equivalent resistance tends to increase. So these 2 are connected in series, means its equivalent diagram would be somewhat like this. This is 5 ohm, 5 plus 2.5, it will give us 7.5 ohm. And this is the equivalent circuit, right? This is A and this is B. You need to follow step by step. Now students look, 5 and 7.5, these 2 are connected in parallel. So their equivalent resistance would be 7.5 into 5 divided by 7.5 plus 5. So it is 7.5 into 5 divided by 12.5. So it will be 5 will get cancelled, so it will be 3 ohm. So the resultant of these 2, which are connected in parallel, is 3 ohm. So we are left with, this is 5 ohm, and the resultant of 5 ohm and 7.5 ohm in parallel is 3 ohm. Now there is no doubt that these 2 are connected in series. So, in the beginning of the numerical I have told you, this branch containing resistor, that is AB, is to be solved in the last step, right? So, the equivalent resistance between A and B is 8 ohm. So, this is the correct way of approaching such numericals, right students? So, first question is done. The equivalent resistance is 8 ohm, right? Let's try to attempt the second question. Check the second question. We'll proceed in a similar manner. In this question also, we are supposed to find the equivalent resistance between A and B. Now, resistors are said to be connected in parallel if the resistors, the 2 ends of the resistors are connected across the same 2 points. That is, the potential difference across the resistors connected in parallel should be same as that of the applied voltage, right? So, now look at these resistors. Suppose this is point O. This is suppose point O, right? Consider this resistor, its one end is connected to point 2. This resistor, its one end is connected to point 2. Consider this resistor, its one end is connected to point O. So what you do is, it can be modified in this particular manner. Try to just stretch it. Try to stretch it or try to open up the circuit. So it is equivalent to this one. Okay. These two, consider these two resistors. One end is connected to point O, while the other end of these two resistors are connected to point A. So these two resistors, their ends are connected to the same 2 points O and A. Therefore, they must be connected in parallel. This is A2, this is point O, and this is A2. This is the point O, right? And then over here it's 4 ohm. This is 4 ohm, and then this is point B. Now 12 ohm, it's connected between point B and point A. So it's like this. This is 12 ohm. So this is the equivalent circuit of this one, right? Now it becomes much more simple. 8, these two are connected in parallel, so their equivalent resistance would be 4 ohm. 8 multiplied by 8 divided by 8 plus 8. So that will give us 64 by 16, that is 4. And remember students, do enough practice so that you can verbally get the answer without doing any sort of calculation. So remember some important tricks. If the two resistors of equal resistances are connected in parallel, then the equivalent resistance will become half of the given value. So here 8 and 8 are in parallel, so the equivalent resistance would be 4. So its equivalent resistance is 4 ohm. This one is also given to be of 4 ohm. And this is 12 ohm. This is point B, this is point O. Now there is no doubt that these two are connected in series 4 and 4. So their equivalent resistance is 8 ohm. That is, this will become 8 ohm and this is 12 ohm. So now the equivalent resistance would be R1 R2 divided by R1 plus R2. So that is 12 into 8 divided by 12 plus 8. So 96 divided by 20. So it will be 4.8 ohm. 4.8 ohm. So simple students, right? So the equivalent resistance in case 2 between the points A and B is obtained to be 4.8 ohm, right? Okay, so second question is also done. Let's proceed with question number 3. Another very interesting question. Same way we'll proceed as was done in question number 2. So concentrate on that particular diagram. Look, I've told you, if the given resistors, if their ends are connected to the same 2 common points, then they must be connected in parallel. Now check that diagram, question number 3. Look, all the 4 resistors, its one end is connected to point A and the other end connected to point B. Other end is connected to point B. So it is equivalent to 4 resistors which are connected in parallel between the points A and B. So the equivalent circuit diagram of question number 3 is, this is suppose point B and this is suppose point A. All are connected in parallel and there are 4 resistors, each of resistance 10 ohm. So the equivalent circuit diagram would be as shown, right? Again, I must convince you, one end of each of the resistor is connected to point A, the other end is connected to point B, right? And there is no circuit element on the circumference of the circle. So the other end of all the 4 resistors are connected to point B. So all the 4 resistors, their 2 ends are connected to the same 2 points A and B. So the equivalent diagram is like this, A and B. The 2 ends of all the resistors, 4 resistors are connected between points A and B. So that's the condition for parallel combination. So in parallel we are aware 1 by R parallel is equal to 1 by R. 1, in this case all the resistors are same. So 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10. So 4 times. So 1 by R parallel is equal to 4 by 10. So R parallel would be equal to 10 by 4. That is 2.5 ohm. Right students? Actually, I will recommend you to do such numericals verbally without doing any sort of mathematical calculations. How to proceed? I'll tell you. 10, 10, they're in parallel. So the resultant is 5. Again 10, 10, their parallel resultant is 5. Isn't it? We are left with 5 and 5 which are in parallel. 5, 5 parallel, it will give us a resultant of 2.5. That's the answer which we should get. So students, simply you need to do enough practice of such questions. You yourself will become confident and it will be too easy for you to solve such questions. Right? So, third question is also its equivalent resistance is 2.5 ohm. Now let's concentrate on the fourth one. Let's concentrate on the fourth question. Okay. Fourth one is this one. Now look, this is the point O, suppose the intersection of this diagonal. Now consider on these two resistors. The one end are connected to point O and the other end is connected to point A. So these two resistors, their two ends are connected with the same 2 points A and O. Therefore they must be connected in parallel. So these two are in parallel. Similarly these two are also in parallel. So the circuit can be modified in this following manner. This is 5 ohm. This is 5 ohm. This is point A and this is point B. Okay, these two are in parallel, right? So it can be redrawn like this. This is point O. Again, these two are in parallel. So it can be redrawn in this particular manner. 10, 10, 10, 10. Right, students? The circuit can be redrawn in this particular manner. Right? So these two are in parallel, no doubt regarding this. So it can be further modified in this manner. This is 5 ohm. 10, 10, it will give us 5 ohm. Again, these two are in parallel, so it will give us 5 ohm. And over here, this is 5 ohm. Right, students? These two are connected in series, no doubt regarding that. 5, 5, their resultant resistance when they are connected in series would be 10 ohm. So what we can do is, okay, I'll draw another step. This is 5 ohm. This is 5, 5. They are in series, so it will be 10 ohm. And this 5 ohm. Okay, this is it. So, no doubt, all the three are connected in parallel, so the equivalent resistance can be easily obtained. Now look, you can do it verbally. 5, 5, their equal resistance connected in parallel, so the result will be 2.5. 2.5 and 10 are in parallel, so the result will be 10 into 2.5 divided by 10 plus 2.5. Understood that? So, which will give us 10 into 2.5 divided by 10 plus 2.5, which would give us 10 into 2.5 divided by 12.5. So, it should give us 2 ohm. Right? Let's solve it in the conventional method. This was verbally, right? Let's solve it in the conventional method. So, 1 by RAB, it will be equal to 1 by 5 plus 1 by 10 plus 1 by 5. It should give us the same answer. So, let's consider this here. 10, 2 plus 1 plus 2. So, it will be 5 by 10. So, taking reciprocal, what do we get? 10 by 5. Therefore, RAB is equal to 10 by 5, which will give us 2 ohm. So, either way, students, again I must request you, practice more and more such numericals, right? You need not to do these mathematical calculations. You can easily solve it verbally or without doing any actual calculations, right? Automatically the efficiency will come. So, fourth question is also done. The equivalent resistance of the fourth circuit is 2 ohm. Let's concentrate on the third one. Let's concentrate on the fifth question actually. Fifth question is relatively very, very simple. You can yourself try that. Okay, fifth one. Now look, there's no doubt that these two, 6 and 2, are connected in parallel. What will be their equivalent resistance? 6 into 2 divided by 6 plus 2. That is 12 by 8. That is 3 by 2. That is 1.5 ohm. So the equivalent resistance of these two which are in parallel is 1.5 ohm. So this circuit can be redrawn in this particular manner. The equivalent of 6 and 2 is 1.5 ohm. It is given to be 3.5 ohm. And then this is 5 ohm. And this one is given to be 2.5 ohm. Right, students? Okay. These two are connected in series. No doubt regarding this. So the equivalent resistance of these two would be 3.5 plus 1.5, which will give us 5 ohm. So it can be further redrawn in this particular manner. This is 5 ohm. This is 5 ohm. And there is 2.5 ohm. These two are in parallel. Again, parallel and having the same value of resistance. So their equivalent parallel resistance would be half of the given value. 5 parallel, it will give us a resultant of 2.5. Therefore, the circuit can be redrawn in this particular manner. 2.5 ohm, and here this is 2.5 ohm. So eventually, last step, these two are connected in series, no doubt about it. Therefore, the equivalent resistance would be 5 ohm. 2.5 plus 2.5, that is 5 ohm. Right? So again, this is based on the same way as we have done the previous 4 questions. So, 5th question is also done. Let's concentrate on the 6th one. Again, interesting one, but we need to modify the circuit into simpler one. So, what to do is, let's change that circuit and try to make some equivalent simple circuit. This is point A and this is point B. Now look, suppose this is point O, right? Consider these 3 resistors. Both the ends of these 3 resistors are connected between the same points O and A. Look, this resistor, its end is connected to point O. All the 3 resistors, their ends are connected to point O, while the other end is connected to point A. So these 3 resistors are connected in parallel because their ends are connected between the same 2 given points, right? So this circuit can be redrawn in the following manner. Consider this to be point A and this to be point O. So each of the 6 resistors having resistance of 6 ohm may be redrawn in this particular manner as they are connected in parallel. So this is 6 ohm, this is also 6 ohm. Now look, between point O and B, a resistor of resistance 1 ohm is given. So this is 1 ohm and this is point. Now it becomes very simple. All the 3 resistors, each of resistance 6 ohm, are connected in parallel. So the equivalent would be 2 ohm. Why 2 ohm? Because it will be 1 by 6 plus 1 by 6 plus 1 by 6. That is 3 times. So 1 by R parallel would be equal to 3 by 6. It is equal to half. Don't forget to take the reciprocal in the last step. So the equivalent of 6 which are connected in parallel is 2 ohm. So what you get is, the circuit can be further simplified in this particular manner. Right? Now it's very simple. These 2 and 1 ohm are connected in series. Therefore, the equivalent resistance between the points A and B would be 2 plus 1, that is 3 ohm. Got it, students? So, we are done with question number 6 as well. Let's concentrate on question number 7. Let us now concentrate on question number 7. Again, we will use the basic concepts of resistances connected in series and parallel. So, in the 7th question, look, consider these 3 resistors. Its one end is connected to point A, the other end is connected to point B. We are supposed to consider that circuit or that loop which offers minimum resistance. Look, current basically always tends to follow that path which offers minimum resistance, isn't it? So you need to consider that loop or that path which has no circuit element or which offers minimum resistance. So consider this resistor of 2 ohm. One end is connected to point A, the other end is connected to point B. Consider this 2 ohm. Its one end is connected to point B and the other end is connected to point A. Consider this resistance of 1 ohm. Its one end is connected to point A, the other end is connected to point B. So what I mean to say is that all the 3 resistances are connected between the same 2 points A and B. And as per the concept, these three must be connected in parallel, isn't it? Therefore, the equivalent circuit would be like this. 2 ohm, this is 2 ohm, and this is 1 ohm. So all these three are connected in parallel. Now, it can be written in this particular manner. What is the equivalent of 2 and 2 in parallel? It will be 1 ohm. Again, I am repeating. If the two resistors of equal resistances are connected in parallel, then the resultant would be equal to half of the given value. You can check it, right? So 2 and 2, it will give us 1, and this 1 is left. 1 and 1, they are in parallel, therefore equivalent resistance would be half of this, that is 0.5 ohm. Right? So that's the answer. So question number 7 is also over. Clear, students? Okay, let's proceed to the next one. Question number 8. Question number 8. We are supposed to calculate the resistance between the points A and B. Look, A and B, this branch is to be solved in the last step. Remember, I have told you initially before the beginning of the numericals, right? AB branch is to be solved in the last and the final step. So, if we are supposed to find out the resistance between the points A and B, it means that source is connected between these 2 points A and B. So, in that case, these two are connected in series and the resultant will be connected in parallel with 3 ohm. So, this particular circuit can be modified in this particular manner. This is point A, this is point B. Between points A and B, a resistor of resistance 3 ohm is connected. While over here, the resistors of 6 ohm and 3 ohm are connected in this manner. They are connected in series, right? So this circuit can be redrawn in this particular manner. So what we get is, these two are in series, no doubt regarding this. So it will give us 9 ohm and this is 3 ohm and this is point B. So RAB would be equal to 9 into 3 divided by 9 plus 3. It's clear, students? So that will give us 27 divided by 12. So that will further give us 9 by 4. So that will give us 2.25 ohm. This is the equivalent resistance between the points A and B, right? So always remember, the branch whose ends are connected between the points A and B, that is to be solved in the last step, right? So what to do is, let's consider question number 9, the last one. This is done, 8th question, its answer is 2.25 ohm. Let's concentrate on the last question. There are 5 resistors which are grouped in a mixed manner. Some are connected in series, some are connected in parallel. So let's try to find out the resultant of 9th question, the equivalent resistance. Now look over here, it can again be modified. Look, it can be stretched like this, it can be stretched like this, isn't it? On stretching, the equivalent diagram would be somewhat like this. This would be 5 ohm, this would be 5 ohm, and on stretching arm with point B as its end point, it would be like this. And these two resistors are between these 2 points, right? It would be like this. This is 5 ohm and this is 5 ohm. So, 9th question, it can be modified in this particular manner, right? So, its equivalent diagram would be, these two are in series. So what to do is, let's redraw the circuit diagram and modify it. These two are in series. The equivalent resistance of the series grouping of resistors having resistance 5 and 5 would be 10 ohm. Now these two are in parallel. So its equivalent circuit diagram would be somewhat like this. This is 5 ohm. This will be 5 ohm. And this one is the equivalent of these two. Now these two are connected in parallel, so their equivalent would be 10 into 5 divided by 10 plus 5. So it will be 50 by 15, isn't it? So it will be 10 by 3. So it is 10 by 3 ohm. Clear, students? Now all these three resistors connected in A and B are connected end to end. Therefore, they must be connected in series. Therefore, resultant equivalent resistance with the points A and B will be 5 plus 10 by 3 plus 5. So it will be 3, 15 plus 10 plus 15, isn't it? So it will be 40 by 3. So it will be 13.33 ohm. This is the equivalent resistance between the points A and B for question number 9. So students, I sincerely hope that I am able to convince you how to proceed with such questions, how to find the equivalent resistance of given network, which comprises of some resistors connected in series while some other connected in parallel. That is, I am talking about mixed grouping. So these were only 9 questions. I will always advise you to practice more and more numericals, right? So let us conclude this session. We'll continue in the next lecture. So please do study well and do take very good care of yourself. Thank you.